Hi, I'm Michelle Wilkerson-Jerde, and for my Grain and Sand presentation, I'm excited to talk about our ongoing project SimSam, bridging student, scientific, and mathematical models with expressive technologies. I've been privileged to work with great colleagues, graduate students, and undergraduates from the Tufts Departments of Education and Computer Science. Our project is inspired by two important movements in the educational landscape. The first is the growing emphasis the community is placing on engaging students in creating knowledge for themselves by engaging in authentic disciplinary practices like conjecturing, developing explanations, and engaging in modeling activities. Second is a growing interest in integrating computational thinking and technological tools into the STEM curriculum. These two ideas have been explored together in interesting ways. For example, we've learned a lot as a field about how students might engage in model-based reasoning when working with simulations, or using data analysis as a way to provide evidence for claims. However, there's been less attention on how students see these tools in themselves as ways to explore, share, and even test their own ideas of how the world works. Inspired by Piaget's constructivism, Papert's constructionism, work that highlights the importance of representational infrastructure on how we interact with knowledge, and movements towards responsive teaching practices, we think this intersection presents an important opportunity for K-12 STEM educators. This leads to the main research question for our project, which is, how can we support middle school students in adopting simulation and data analysis technologies as tools of scientific discourse? To pursue this question, we're conducting a design-based research project in which we develop tools that we hope will elicit the kind of learning we're interested in supporting, studying that learning, and then using our findings to inform refinement of the tool, as well as to develop more general principles for learning environments and theories of learning. I'll focus mostly on tool development today, but if you're interested in the research component, then check my poster out later this week. SimSam stands for Simulation, Measurement, and Stop-Action Movie Making. We argue that while there are some tools that make it easy for students to construct simulations, those tools are usually either very general purpose or are already designed with normative models in mind. For example, many tools to explore kinetic molecular phenomena specifically already use molecules as a building block, even though it's not common for students to spontaneously talk about events in this way. Instead, we want kids to not only discuss, but actually start to make external representations of their own ideas using these computational tools. My colleague Brian Gravel has had considerable success using stop-motion animation to encourage students to construct models of unseen and unheard phenomena like air pressure. This makes their ideas visible to critique and challenge, and gets them thinking in terms of components and processes. Simulation encourages students to think causally and makes it very easy to test whether someone's description of a phenomenon will work in a new or different situation. And measuring what exactly simulations predict can provide even further tests and ways to refine one's theory of a given scientific phenomenon. SimSam seeks to bridge each of these by providing students an integrated tool that allows them to animate their ideas, crop elements of those animations to become programmable objects, program those objects using visual demonstration, and then assign measurements and graphs to validate their models. Our focus is on building an entry point through which they can come to see simulation and measurement as ways of testing their own ideas. In the first 9 months of the project, we've conducted 3 workshops with the purpose of identifying important design considerations and user needs for the development of SimSam. Our first workshop was a several weeks long series of modeling activities with a small group of 6th grade girls. We used existing animation and simulation tools, SAM Animation and Stagecraft Creator, to complete the tasks. Our primary purpose was to test our activities, collect pilot data, and develop analytic tools for later studies. However, we also frequently engaged the girls in design studio activities where they suggested how the tools could be improved and integrated explicitly. Our second workshop was a paper prototyping session with faculty, colleagues, and students at Tufts interested in educational technology design. We showed a short mock-up video that described our proposed design and how we hoped it would encourage students to test and revise their ideas about kinetic molecular phenomena. See, here the user is forced to consider the generality of their model and revise it accordingly. We then videoed groups of 2 or 3 colleagues as they worked to create paper prototype animations of potential interfaces for SimSam. We found this activity particularly helpful in our own thinking, and we took some of our current design inspiration from these proposals. Our third workshop, conducted just this week, was a professional development session with upper elementary school teachers. This time, we used our own SimSam animation module and discussed in depth our prototype of the simulation module. Our main focus was on identifying the supports and questions teachers would have. But we also regularly asked them for feedback specifically about the design and interface. SimSam is already far evolved from separate test modules to a more integrated and user-friendly interface, at least according to the teachers in our workshop. But there's still a ton of work to do. This is where we need your help, and we're looking forward to this workshop. We're interested in knowing things like, what do you think of our ways of working with users? Are there things we may be missing that HCI can help us find out? And how should we move forward? We're still figuring out how best to work with computer science and human-computer interaction students, colleagues, and consultants. How much background do they need to know? Sometimes if a person knows less, it helps us find our blind spots and helps us keep the end user in mind. But it's still important to make our intentions clear. What's a good balance? What's a good development cycle when learning theories are so tightly embedded into your design? So far we've developed things in-house, thinking it's good to have skeletal prototypes to build on. How do you transition to colleagues who might be a little further from learning sciences literature? And of course, what do you think of the project? We'd love to hear your feedback. Thanks for your time, and I look forward to speaking with everyone.